Hey, how's everyone doing today? Today we're going to be talking about the device mapper. All right, so we're going to go to the dev/mapper directory. We're going to do ls here. As we can see here, we have one item called control, and that's about it. So let's talk a little bit more about it. So the device mapper is a crucial part of the Linux kernel. It's a framework and allows you to create virtual block devices over physical devices. These virtual devices can be anything from encrypted volumes to de-encrypt or logical volumes like LVM, but it does a lot more. So what I'm going to show you today is that we're going to use it with LVM. So let me install LVM first. So we're going to install this real quick and I'll show you how it works. And also there's a RAID you can do RAID also with it. If you ever see the directory like MD in the device mapper, it stands for multiple disks. So right now, what we're going to do, we're going to see what disks we have available. So if we do ls block, we can see what we have. As you see, we have XVDA, XVDF, XVDG, XVDJ. So the X stands for Zen, V is for virtual, and then we have the disk, which is A, F, G, J, however they're named. As we can see, we have 3 disks here that we can use. All right, so the way it works, since these are actual, technically speaking, these are virtual also. So it's more like Inception, where we have like the disks and we're mapping it. So what I can do first is let me show you a little sketch so you can see how it kind of works. All right, so pretty much our setup is a little bit different because, like I said, we're using virtual block devices. But let me show you in actuality how it works when you have a normal setup and you're using physical disks. So let's say this is your first disk, which is in your actual computer. Then we have another one. We have 2, and let's do a third one to show you how it works. So these virtual disks that we're using to simulate this lab that we're going to be working with is, just imagine that these are 3 physical disks, even though they are virtual, but let's pretend that they are physical, so it makes a lot more sense. So the way it works is that there's a command that we run, which is called pv create, and that command that we use over here, we call this one pv create. And this command, what it does, it is able to grab the disks that you have and say that you want to start putting a volume group on it. So these are the 3 disks. We have SDA, SDB, and SDC, and we use the pv create command in order to use this as a pool. So what this does, it starts combining the data here. So let's say that this is 20 gigabytes. This one's 20 gigabytes also, and then we'll go over here. And this one's 20 gigabytes also. So we have 3 disks, and these 3 are each 20 gigs. All right. So the next thing, when we run this command, you specify which disks that you want to use. Is it SDA? Is it SDB? Is it SDC? If I just want to use this as a PV create, right, or a physical volume create, what you do is that this 20 gigabytes that you use, you can basically partition more partitions in here, but it wouldn't really make sense to use one. So in this instance, we're going to use all 3 so you can see how it works. So once we run this command, right, now this becomes a physical volume that you're allowed to use. These 3 disks are something that you're allowed to use, okay? The next command that we can run for this, so pv create just tells the system that these disks are ready to be used. That's all it does. The next command that we use, which is the most important, is called volume group create. Now this is where you create your pool, pretty much. All right. So when you create your pool, you can choose which disks you want to use. Do I just want to use SDA and SDB? Do I want to use SDB and SDC? Do I just want to use SDA and SDC, you know, and combine them? But in this case, we're going to use all three. All right, and once we do that, we're going to call this pool, you can call it whatever. Let's call this pool, we'll just call it pool to make it easier. This will be the name of the pool. We'll call it pool. And when you combine all these together, we have 60 gigabytes of data that we can use, or like storage we can use. All right, so this is enabling all three disks to become this virtual group over here. All right. The next thing what we can do, now the next one's even pretty cool. So the next thing is called logical volume, which is the last step. This is where you make your, you know, your partitions and all that stuff. So we call it logical volume create. Now we have 60 gigabytes and we can do whatever we want. We can partition some virtual disks up here, and we can, this one, when we create it, there's a command that I'll show you how it works. I can give it, let's say 4 gigabytes, right? And I can call this logical volume, whatever I want to call it. I can make another volume here. Let's say this one is 12 gigabytes. So you can pretty much partition out whatever you want from this pool. And the great thing about Logical Volume Manager, you don't have to worry about how this is working underneath. All you have to know is that you have a pool of 60 gigabytes and you can add as many partitions and stuff that you want, right? And the great thing about it is that if you run out of storage, you add another disk. Let's say you want to add another disk. And now we're going to add another one. We're going to call it STD. And it's going to be, let's say, 40 gigabytes. Now we readjust this and we add this volume group, readjust this to make it bigger to account for this new physical volume. And we add this to the pool. Now that when we add this to the pool, this would be 100 gigabytes of a pool that we have that we can use and do whatever we want with. Okay. And like I said, these are just partitioned out. So now that I partitioned this out, now the next thing you can do, if you go above a layer, we can put a file system on here. Right above this, because it's 4 gigs and we're going to put a file system. We're going to do make fs, make file system, and we're going to make an ext4. Now that we make a file system here, now we can mount this file system into any directory that we want. So let's say we want to mount it to, we'll call it, and we want to mount it to photos, right? So we can mount this directory into the photos. So as you see here, we have all the physical volumes, and then we pick which ones we want to use that are available. You can make more than one pool. You don't have to use all this from one pool. You can make one pool from these disks and make one pool from these disks. If you really wanted to, you could do that also. So there's no like set way of doing it how you want to do it. You can do it however you want. So if I did that, I can have a 40 gig pool over here, and then copy and paste this over here. I'll make another one over here, and this one will be a 60 gigabyte pool. You could do that. And then let's say I want to make another disk, and it comes from this pool. So basically you can have 2 separate pools if you want. And like I said, if you run out of data, you can get another disk and add it to whatever pool that needs more data. All right, now you might be asking, how does this work with Device Mapper? So the way it works with Device Mapper is once you make this LV create, right? Once you make this, what happens in the system? What happens in the system is that this LV create goes into a directory called DevMapper. And then from here, the way usually it's named, it has the name of the pool. So the first thing is the pool, and then it'll have like a dash, and then the name of your LVM. Let's say your LVM, I'll call this one, let's call this one LVM1. I'll call it LV1. So that's how the system is able to communicate with this partition. So let's say this partition is LV1, this is LV2. I'll put text here. We'll call this one LV1, and we'll call this one will be LV2. Let's see if we put something here. We'll call this one LV2. So logical volume 1, logical volume 2. As you see here, if I want to access this disk, as you see, is called logical volume 1. If I wanted to access, let's say I wanted to access the second one, right? That's how it will work. So you access the second one, right? But when you're accessing this, right? When you're accessing this, there's already a file system on here. So that file system and that directory is already on that actual logical volume, right? Technically speaking. But the way it works is that when you're trying to put this file system on there, you have to get it from here. So dev mapper pool logical volume 2. This is the directory that you use to make a file system. So I can do something like this. You run a command, and we call it make fs, make file system, ext4, and then you put the directory, which will be dev mapper pool LV2. Once you do that, then this command, you're able to put a file system on this logical volume, right? But device mapper is the intermediary where pretty much it does everything. So when you do that command, it speaks with device mapper, and device mapper is able to speak with the logical volume, with the virtual. This is the actual virtual device, right? And how it works is that this device mapper is able to go to one of these disks and put the data somewhere here. I'm not sure what algorithm it uses, but it's able to put the data here somewhere. So when you're accessing that data, it goes to the logical volume and it knows exactly what disk is on it, or if it's on multiple disks, or however the algorithm works. But in a nutshell, this is how LVM works with device mapper. Like I said, the device mapper is in the middle. All right, now we're gonna go to a actual example and show you how it works. So now that we're here, we're going to be in the mapper directory. So we do pwd, we can see that we're in the device mapper directory. Now that we're here, what we can do is start creating physical volumes. So remember, when we do ls block, we have 3 disks. Just pretend these are physical disks, and we have 3 of them. And the first command we do is pv create, because we are telling it that we want to use these disks. And we have to give it the full path, exactly where it's located. So we're going to do dev xvdf, xvdg, and then dev xvdj. Once we do that, you see there's 3 physical volumes that are created. So now when I do that, I can do pv, and then you can run this command. You can do display. And once we do this, it tells us that there's 3. So we have one is 20 gigs, and it says, it gives you all the data on here. And then we have another one that says 20 gigs. And then another one, 20 gigs. All right, now this is where you make the volume group. Remember, we have 3 disks, so I can use 2 disks to make the volume group. So I can do vg create, right? And now what we can do, let's look at the syntax. So we're gonna call the volume group pool. And then the next command is the physical volume. So the next one is like dev, we call it dev xvdj, and we're gonna use xvdf. So we're gonna make it out of these 2 disks. So we're gonna make a pool out of these 2 disks, and then if I wanna add more data, I can. So this is just to show you how it works. So once I do that, as you can see here, we made a volume group called pool. Now if I do vg display, right, you see here I only have 40 gigs that I'm allowed to use. This is my volume group size. But hey, let's say I want to add another disk to it, right? So the command that you can use here would be vg extend. So I can do vg extend. Then we check the syntax, and then I want to extend it to the volume group pool, and I want to add this disk called xvdg. So once we add that, as you see, it's added it to the pool that we have, and it's called pool, so it is a little confusing. So now that we go to the vg display, that's pv display, so we're going to do a vg display. If we go here, we can see now it's 60 gigs that we can use. Now, also, if we go to the PV display, which is our physical, as you can see here, it tells you disk physical volume is now located or allocated to the volume group. As you can see, the volume group pool. I could put this one in a different volume group if I wanted to, but I didn't. Now, if we do ls, you see, you still don't see nothing in the mapper because what it needs is the actual logical volume. The last one, what we're going to do, we're going to use the LV create, which is logical volume create. So let me look at this just to make sure I have the right syntax. All right, cool. So what we can do now is we can add the size. So this is the syntax that we use. So we'll do LV create. And then the volume group will be from pool because that's the volume group that we're going to use. And then for the size, we're going to add, let's do 4 gigabytes. All right. Oh, I gotta give it a name too. Let me save this real quick. And let's see how we can give it a name. Because we want to name our logical volume. If you don't name it, it will name it for you. So what we gotta do is look for a name. So let's look for a name. What we can do is do man, and then we're going to do LV create. And then let's check for a name. So let's do name. Okay, let's see. Name, there it is. So -n. So we're going to use -n. This will name our logical volume. Make it a lot easier for us. So let's give it a name. We'll call this LV1. Well, now LV1 is created. Now if I do ls, you can see here, this is how it's named. It's by the volume group, and then now we have LV1. So as you can see, this is a physical device. Not physical device, I'm sorry, the virtual device. So this is the virtual device, as you can see. So the virtual device here speaks to the physical device, which is done through device mapper. As we can see here, PWD, we're in the device mapper directory. And as you see, this is our logical device. So if I want to make a file system, I'm going to do make fs ext4. And if I make it, I got to make it onto this pool. So when I do that, as you can see here, if I do ls, I made a file system on this. There's a file system on here. Now, if I do ls block, as you can see here, on XVDJ, it was made on this disk right here, and I made a pool on this one, or a partition. The partition is LVM. So now that I made this partition under the pool, under the device mapper, we can see here, this pool LV1 now is accessible to be used. Remember, this is the pool name, and then there's the logical volume name. So now we can mount this. If we want to mount this, we can. So we can make a directory, and we're going to call it MNT, and we're going to call it photos. Now that we made this directory, we can mount it. We can use the mount command, and then the way you mount it will be, the first thing will be where this is located, which is dev mapper, and then pool, and then we can do it to photos. As you can see now, it's mounted. Now if I do the ls block, we can see now this virtual partition is mounted here to mount photos. Now we can go to this /mnt photos. Now we're here in this partition, and we can touch a file called test1.txt. As you can see here, we are now in mount photos. Now if I go to ls on device mapper, you can see here, this is where it's located, which is actually pretty cool. And this is actually a symbolic link. If we do a file, device mapper, pool, as you can see here, it says it's a symbolic link to DM0. So DM0 is device mapper 0. And if we look at that, we can go to, let's go to device mapper real quick. So yeah, this is the file. So the device mapper was a DM0. So let's check device. Let's see if we have DM0. So as you can see here, here's the DM0. Then we can do a file on DM0, see what kind of file is a block special. As you can see here, DM0, this is where your disks are. So this is created, and this is how it communicates with it. So it has a device mapper 0. So this is related to this. And that's how it pretty much works, because this is just a link, and this links it to here, DM0. And that's the block special device. And that's it in a nutshell. Like I said, device mapper is used to map virtual devices to physical devices. The next one, I can do another device mapper series, but we'll talk about Lux encryption and how that works with device mapper. Thank you guys for watching, and have a great day.